All right, so the topic of today is going to be, so we did like distributing geometry. That was what you guys were covering for Tuesday. Today we're going to take that geometry that's been distributed and we're going to apply some logic to it to generate different kinds of patterns from it. Okay. So again, in order to start looking at that, I want you guys to get this pattern going. You're going to make a row of columns, just a lot of them. And you can think of these as columns or just lines or whatever. This is just for demonstration purposes. Okay, so I'll give you guys a second here. So again, make a curve from 0, 0 to 100, 0, 0. I mean to 100, 0. Like a line. Reference it. Add a divide curve component. Number slider for the number of segments, and then just add a cylinder, and then set that to 20. Give you guys a second to get caught up here. The first part of today, we're going to be talking about these patterns. I'm going to show you these different kinds of like list components, and then we're going to be showing what kind of output you get from those. Then we're going to do a demonstration of it by making like a simple kind of railing system, and then we're going to look at a facade using this stuff, a facade study. And that's going to be your homework for this week, is going to be a facade study. And this is similar to your column study from last week in that you're going to create a parametric system that looks at a facade. You're going to create 3 variations of it, and then you're going to make a 3-page PDF. Okay. I'm not sure that'll always be the way we do things, but that's what I'm going to do for this week. So, and again, the idea is to look at patterns of distribution now, instead of just raw sort of like distribution of objects. Okay, are we getting there? Divide curve, cylinder, and again cylinder set to 20 high. Just keep it at 0.5, it's fine. As long as your units are regular units, it should be fine. Okay, most of you guys have got it. Anybody stuck? I'm gonna keep going, and hopefully we'll get caught up here. So this is the basic pattern for today. Go ahead and set your camera to front view. You can just type in front, and then just kind of keep that zoomed in. This is the way that I want to look at it right now. I really just want to see these as a row, as a line of things. Okay. So divide divides my curve into points, and then those points are used as the base plane for the cylinders. Okay. What we're going to look at today are these tools inside a sequence, and there's a couple of different ones. And the first one I want to start with is called Cull nth, and Cull means to remove something from a list. And again, these are just lists. Like this is a list of points, and then that list of points goes into the cylinders, and it creates a list of cylinders. So once I have a list, I can decide to remove certain things from that list, and that's going to create a pattern for me. So a Cull component takes a list. And then this one takes the Cull frequency, and that's like, so it says like, turn off every other one. If I set that to 3, it'd be every third one. 4 is every fourth one, and so forth. Let's see what that looks like. So plug the points into it, and then plug the new list into your cylinder, and you'll get the different pattern. And then let's add a whole number slider to that. We can just copy that and make that 20 or something. Now you'll see if I go in. So again, this is turning off every one, every other one, every third one, every fourth one. And so you get these interesting patterns. It's kind of, you actually get like a rhythm going with it. Okay. Now again, I have the points, I turn off some of the points, and then I use those to do the cylinders. You could take the cylinders and then turn off some of the cylinders, but that's more computation, right? Is it easier to make 100 and then turn off a few, or is it easier just to actually make 50 cylinders or like 75 cylinders, right? So you want to think about that. I mean, at this stage it wouldn't hurt, but when you get a bigger model, you want to be thinking about the order of these things. Okay. So again, we have a curve that's been divided, and then we change that list of points, and then we get cylinders. Okay. So Cull n. So that's a nice pattern. You could have like these doublings of things, like you see on the outside of like Renaissance buildings, or more and more complicated patterns. Okay. Okay. Let's go ahead and take that pattern. Let's take it and pick everything, and then right click and say preview off. Now this is different than just turning off one thing, right? We're going to pick everything, and then you click somewhere else and you say preview off, and that's going to turn off all that stuff. You can see everything turns gray. Okay. And then let's copy it, and then paste in place, and then hold the shift key, and that's going to give us a copy of all that we can play with. So we're just going to keep all these in the same file for now, just so that we can keep moving here. And let's erase the Cull n component. Delete that. Now we're back to just our row of points, and then let's look at the next component, and that's Cull pattern. So go to sequence, Cull pattern, then put a Cull pattern in there. Okay. Cull pattern takes a list. I mean, all these take lists. And there's this culling pattern, and right now it's false, false, true, true. Okay, false means it's turned off, true means it's turned on. So if I plug in that list, you can see that false, false, true, true, false, false, true, true. Okay, so that's what and then if I plug that into my cylinders, and I need to turn my cylinders on, I get that pattern. Now, not too exciting, because right now that looks like Cull n, but if I take that pattern, and you can do like a right click on this and then go to set multiple booleans, click in here, and then you can type in false, true. So again, 2 on, 2 off, 1 off, 1 on. You get a much more complicated rhythm. Okay. So again, take the Cull pattern and plug your list into it, your list of points from the curve, and then plug your list into the cylinders, and then you can do set multiple booleans, and you can play with that. You have to type in true or false for that to work, and you can erase it if you want to. Like you can go through and you can delete these, and then you say commit changes. Okay. Another way to do it is to go into parameters, take a panel component, and you can plug it in, and you can actually write your list in here. You can say true, false, true, true, false, true, false. Make it as long as you want. And it's going to repeat over and over again, and then when you're done with that, just say like multi-line data, and now that's actually like a data component. And the advantage of this is that you can see what the test is. Like this thing actually sits out there. Okay. So just make sure when you're done, you need to right-click it and say multi-line data. Okay. Otherwise, it's just text. It's a difference between a comment. This is the one, PJ. There you go. So right-click it. There you go. And so that's how you make that a list. Oh, one thing too is if you have that in your box, make sure that So just right-click multi-line data. Okay. It has to be true, false. It has to be spelled correctly. There's no spaces. It has to be correct. Okay. I think it has to be capitalized too. That might be your problem, PJ.
It doesn't.
No, it doesn't have to be capitalized. Okay. It does have to be spelled correctly. Okay. So that's a Cull pattern component. And you can go ahead and let's go ahead and turn this one. Let's turn preview off. Let's take this again, copy, paste in place, move another one down, and then let's delete this. And let's add another one. Let's go to sets, sequence, random reduce. And random reduce is, it takes a list. It takes a number of items to remove, and then a seed. And the seed is just kind of a number that goes into the random algorithm that just says like which ones to remove, and it's a way of kind of preserving a certain randomness. We'll see that in a second. So take your list of points, plug it into the list, and then you plug that into your cylinder again. And I need to give it a number of items to remove. And so now you look at this, and it's just going to randomly remove 5, randomly remove 7, just random, okay? Now, make a copy of that, and then look at the seed part. So it's going to remove 20, but if I change the seed, it removes different. It removes, different ones. It's kind of a weird way to do randomness. You guys probably aren't used to that, but it's, again, it's just you have a list. You tell them, you tell it how many to remove, and then you give it a number, and that changes the pattern. So let's say like you don't like that randomness. You can adjust this until it's a little bit like more to your liking. Okay. Again, really different than the way we did it with processing. So that randomly removes something. And again, I want to stress that this works with any list of things, like anything you have. So if you actually like divided a surface into points, you could feed that into this, and then you could randomly pattern them or randomly like reduce them or something. Okay, or you could do like a Cull nth on that as well. It works on geometry. Anytime you have a list, you could do patterns in those lists, and that's what these components do. Okay. Any questions on these? We all still following along? Okay, one more trip around. Let's turn this off. Copy, paste. Shift, copy. Let's delete this one. Delete these guys. Okay, the last one I want to talk about is dispatch. And dispatch is under list. It's under sets, list, dispatch. And dispatch is a different kind of logic. So instead of turning something off, we are going to take a list. So take your P, take your list of points, plug it into the dispatch. And there's a mask here again. So there's a true-false pattern, which we can change just like the way we changed the pattern before. You can use like a multi-line box, or you can use like set booleans, okay? And that's going to say anything that's true gets piped out to A, and anything that's false gets piped to B. So we're going to split a list according to some kind of criteria, okay? And think of all the tests that we can do that can make things true or false. So this should be really interesting. So we have, let's take our cylinder, and we'll like plug it into A. I'm looking at this. What is wrong with this here? Hide this here. Okay. Something broke. Take my list. Oh, because I turned that off. That's why. Okay, set boolean. Yeah, I accidentally deleted the test here. True, false. Let's do true, true, false. You can do any pattern you want, but okay. So that's going to give me this, and then let's make a copy of this, and let's change the. You can change the radius.
Where are you going to type in true, false?
If you do like a right click here, then you say set multiple booleans. You can do it that way. It's just like the pattern one. It's the same exact thing as this. You could also do a panel component, and then if you have your list here, pipe B into that, and then check that out. So now you have a pattern of two different columns.
When you did the pattern one, I couldn't find the little note thing, so I did it the other way.
Yeah, it's fine. You can do it. You can do it either way.
Oh.
You can do a panel too.
Oh, that's it.
You can do
I couldn't find it.
panel is under parameters, special panel. Again, you can plug this in, and you could say false, true, true. Change that to multi-line data. Whoops. And that's going to work too. Now, see, you can have two different kinds of geometry. Now, it doesn't have to be two columns, right? I could have like the A be like a square column and the B be an arrow column, okay? And I get a pattern of this according to some kind of logic. I get two different kinds of geometry. I could go in and I can make this parametric, And I can make all these like, lower than that. There are all kinds of things I could do. And I could even take the dispatch. I could take A, and you better believe I could take a dispatch and plug that into A, and I could split that other list even further. And I could split B, and I could split like that other one. And I could split it as many times as I want to get any kind of complicated pattern I want. And then I just plug the geometry into it. Okay? And we'll see later on, if I can figure out a way to generate a list of true-false values, and I plug that in. So let's say that like if something is near a point, it's true, and if it's further away, it's false. Then I can decide which geometry I want to use according to that true-false test. Okay. So really, really, really powerful stuff. And this thing is still parametric. Like I can still adjust. Let's not forget that. I can still adjust the number of things if I want. These can be parametric. Okay. So it's a really good way to study these kinds of, when you want to look at like a rhythm of something. And that's what we're, really going to be doing for our homework assignment. Okay. Any questions on these kind of patterns, on these kind of distribution patterns before we move on? So just keep this file, you might want to save a copy of it for yourself. And this is just a good demonstration of what these are. You can certainly like combine these in different ways, but this is just a good reference for you. Okay, I'm gonna go ahead and actually I'm gonna start a new document. I'm gonna keep my line, and let's actually before I do that, I'm gonna go ahead and hide this. I want us to be looking at rectangles. And so I want to show you a pattern so we can use rectangles. Okay. You can just make a new file. You don't have to delete it all. That's the easy way to do it. Just make a new file. So just make a new file. You can save that old one. The rectangle is something I kind of avoided earlier because it like behaves really strangely. Circle is really easy because it has a center, it has a radius, it's very easy. But rectangle, if you put a rectangle component in your sketch, it has a base plane, but it does this thing with like domains where it wants like a domain and in the x and one in the y. So instead of a width and a height, which would make sense to me, it wants a domain. And so you can see that the it's kind of small here, but my x domain is -1 to 3, so -1 to 3, you can see the cells here, and then the y domain is 1.5 to 2. Yeah, so it's a really crummy way to do it, but I'm going to show you how to use it. So because a lot of things we do are like rectangular or square or something. Okay, so base plane we know about, but let's look at how we get like the domain. Now we're going to add like a domain to it. Make sure to add this kind of domain, because that's actually the domain component. This is a reference to a domain, so just add this domain, not the black hexagon. So we have a domain that says start at A, end at B, and that's your domain. Okay. So let's plug in a number slider to it, and then let's plug in a number slider that goes negative. Or actually, let's just make 2 copies of this, I guess. So just make a number slider that goes from -1 to 1, and then copy it. And let's plug one into A and one into B, and you can see that now it's happy. And then let's plug this in for X. Now nothing's happening, but I need to, if I go negative, so I go beyond that, and then I go positive, you can see how that works. If I copy this whole structure here, plug that in for Y, you can see the same thing. So now I can actually look at like that. So that gets it kind of centered on that. If I have a negative number and a positive number, that's going to center it. I'll give you guys a second to catch up there. So again, I have a slider that goes from -1 to 1. Plug it in for A and B in that domain. Plug the domain into X. Plug another copy of that into Y, and that gives me a parametric rectangle that is centered, wherever P is. Okay. Now we're going to do this even more intelligently. I just want to show you explicitly like how this works, because it's a little terrible. But the logic of that should make sense to you. Okay. You don't need to do all this. I just want to show you. So again, if we go negative, If we move that negative, move that positive, that changes that domain. Okay, so a really a nice way to get width and height that's kind of hacky that I like is I'm gonna make the slider just go from 0 to some number, let's say 3. And I'm gonna erase all these other ones. I just have one slider that's positive, okay? And then if I plug this in for B, now nothing's gonna happen here. But if I change B, if I say B is negative B, and then let me just copy this structure here. This is a hack that I like quite a bit. So then now you have width and height, and that's more computational. So again, what I did was I have a number that's a positive number. I plug one end into A, and then I do negative B in the expression editor, and then I make that my X, and then a copy of this is my Y. Okay. Now, if I wanted to make a square, it'd be even easier. Bless you. I just plug these in, and now I can make a square, right? Because the X and the Y domain are the same. Okay. So keep a copy of that around in this sketch here. I'm going to keep these. So keep something like this around. And let's just shuffle that off to the side. Okay, so that is our template. That's our pattern for a parametric rectangle, right? And let's go ahead and turn preview off that.
I have a quick question.
Sure.
What exactly down at the bottom? The little circle.
This thing?
Yeah.
It's kind of a compass. It just shows you like where you are in the world.
Oh, okay. All right. And then I was when I was trying to mess with this thing and right clicking, I think I've got this.
This navigate thing? Yeah, this is just a map.
Oh, like a zoom diagram.
Yeah, when your sketch gets huge, you need things like that to help you understand like where things are.
Okay. All right.
Ours won't get that big, I hope. So, but that's just a navigational aid.
Okay.
Okay. So let's go ahead and show. We should have a line again. Like this line. Delete. I have an extra copy here from last class, so I have a line that I made. And let's go ahead and let's look at, we could think about a simple kind of railing. So let's do a curve. And we're going to reference that curve. So we're going to just have a curve component. And then let's divide it by length this time, though. And let's put a slider in. Because a railing, we don't care about the number of things. We care about someone fitting their head between the railing rails. So we need to look at the distance of this, okay? And then last, we could take a cylinder if we want to. And let's make that, and let's make it parametric. So we'll put in one for the diameter. We need to make it really small. And then let's put in another slider and modify it for the height. And you guys should be getting like used to this kind of thing. This is the pattern that we've been doing. This is essentially like the row of columns we just made, only it's more parametric. So the length between, oops, I'm going to show front view. So the length between these guys and the radius of these, make it more railing-like, and the height of these. Okay, and so that's a basic parametric kind of, that's a basic template. Okay.
I'm not sure what.
Did you reference your curve? You gotta have a curve in there, otherwise it can't do anything. All right. Okay. For now, let's go ahead and hide this. And in fact, let's go ahead and hide this. So imagine that we're working with like some lines that are just basically like some datum lines. Okay. So the curve is the ground line. And then what would be the line that's the height of the railing? Like, do we want the actual rail that actually goes across this thing? If we wanted to make that line, how would we do that? So we have a line here, and I want a line that's the height of the railing. Like I want like this line right here. Does anybody know how to do that? If I have a line on the bottom and I want it here,
Scale it, if I move it.
move it. Yeah, right, because move is going to change the state of it. So let's take that curve, let's move it, and we're going to move it in what direction? Yeah, up, Z. Up and Z. And what's the height of that? Like, what should I plug into this to get the height of it? Height of the cylinder, yeah. So now, if I look at my thing, right, it's parametric. That's the height of the railing, okay? And I could do something simple, like, so I got that line there. I could go through, and there's a command called pipe. And I could, if you plug that in, basically what it does is it just makes like a circular cross section of something. It's kind of a simple way to make some geometry. I'm going to plug a different radius into it though, because it's chunky. So if I look at that, now if I look at this in perspective, you can see that it's actually got like a railing thing. Whoops, I lost my thing here. So that's kind of smart. Like it's parametric. You know, I can move this up and down. Okay. So that's really basic. What I can do though, I can do a couple more interesting things with it though. So I can take my line. Well, let's go ahead and start. I mean, you could take the cylinders that you made, and you could actually call them to get a different pattern. So I could go in and I could put this list of these in here, and I could do that kind of pattern, or I could do, maybe I want a pattern of like 4 of these. And so now that becomes more interesting as a rail. So again, you're just gonna call those cylinders. Let's make it more interesting. Like everything right now is kind of circular, and that's not really right. So let's look at this again. Let's go ahead and hide everything. Turn preview off. And let's just look at this line that we got. Okay. Now, one thing we'd want is kind of a footing for this, like something that it gets poured into. We might want something that's actually like rectangular, right? That this thing sits into. So what you want to do is take a rectangular section and put cross sections along here, and then basically, it's sort of like a loft. We would loft across here, but instead of a loft, we're going to do what's called a rail sweep, and a sweep is like a loft along a particular curve. Okay, so let's look at that. But in order to do that, we need to get the rectangle, which right now is the shape that is like at 0, 0, 0. Right? It's this kind of thing. And we want it to be oriented to this line that we made in the ZY plane. We want that to be sort of like perpendicular to it. And luckily, there's a way to do that that's really easy. Let's turn this off. So we have our curve. Go to curves. Division. Same as we've been looking for divide curve. We want to do perpendicular frames. And plug that into your curve. And you can see we get perpendicular frames, right? And if we have a plane, we can plug in our rectangle. And let's unhide it now. And you can see that we have a lot of these things. That's starting to get us the cross section that we want, okay? So perpendicular frame, you get frames, plug it into your rectangle that you made, and you get a list of frames, okay? And again, your frames have to be plugged into your curve. And that'll give you your frames, okay? Now, how's everybody doing with that? If you're, so we don't need all those though, because this isn't changing. We just need one at the end, and one at the start and one at the end. So let's just take the number of frames and set it to 1. So you just get, right? That makes sense. Like from here to here, you're going to make an extrusion. You're going to make a like a loft.
You mark it
Number, like n in the frames. And then I set it to 1. This is just an easy way to do it. Okay.
Just had a distance between the two frames.
It's not. It does it by number, so that it just basically subdivides whatever that curve is by the number of things. So if I had 10, it would be. It doesn't do it by distance actually. There's ways to do it by distance, but this is simpler because all I care about is the start and the end. Okay. So then I have my sweep. Okay. So sweep 1, because it's one rail, and the rail is the curve that it's going to be swept across. So R is my rail. So take the curve, plug it into rail, the original curve, and then take my rectangles, make both of them, plug those into sections, and you can see I've got this like tube. And let's turn off planes now. Those are annoying. Okay, so again, to backtrack, we wanted a sweep, and that requires a rail, which we have, it's easy, and then the sections, which need to be aligned on the rail, and we aligned our rectangles by using the perpendicular frames, which are taken from the curve, and that gives us our section. Now let's go back and turn on our stuff, and we'll see how horribly off scale we are. Yeah, it's ridiculous. So let's go in, and let's parametrically alter our section to be more conducive. Okay, so now you've got that section. So now you've got different, more intelligent sections. Okay. Okay, one last thing with this that I want to show. So that's a thing. Let's make it more interesting though. Let's add some more horizontal separation. So I got my geometry that I made, which is this like swept thing. And we could do something really simple, like we could just move it. You take it, and let's do a Z, and let's add a number slider with some kind of dimension. You don't have to do this part, but I just want to show you. So you could take that and you could do a different section, but you can move that and you could experiment with that. Maybe our pipe gets bigger then if that's the case, like if that's how we use it. Okay, so that's a vertical separator. So you could do that. Take that section and copy it. You could actually take that line and make another section, a different rectangle that's a bit thinner. That's a different section, and make that your piece. Whoa. But see, that's fully parametric too. Okay, maybe that's what we want instead. Okay, but let's do something even more interesting. So that's one way to do it. And then there's the more power way, where we take a series and let's adjust it. So again, if we plug in a list of numbers, we can move these things, and we make lots of copies of it. Okay, so let's make a bunch of sliders then for this. So we want a number slider that controls the start of the series. Oops, I need to fix that. So that's going to control where it starts, and then one that controls, actually let's make a raw one here, the distance between them. That's more like it. And then lastly, the number of things we have. So I'm just going to say 12 whole numbers. And so we can control this kind of thing. So now it becomes more interesting yet. We have this kind of pattern, and we have this kind of pattern, which again, we can like shift it. You can put it in the middle, you can put it like up here, you can put a gap between like this and that. So there's all kinds of decisions that you can make. And you can cull that. So we can plug this in, And now we can do different things with that as well. Let's plug this in. And now I can experiment with different kinds of ordering with this. Maybe I need more stuff. Those are tiny. But so again, this is kind of a thing that you can do to study something, right? You can look at various horizontal elements, vertical elements, make different copies of them, using some kind of like divide curve or using move to create a series of things, or maybe a range of things, and then you can even go into that and you could change the pattern of it by using one of like your Cull patterns. Okay, so this is kind of a study tool, and you could always go back. Get fully parametric, and you could adjust the height. Now we could probably add some more intelligence to this, right? But look at all the different things that you can do once you start to study this. Now this doesn't just have to be a railing. This could be your facade. You could take a pane of glass and you could divide it up in all these different ways. You could take a strip window and you could explore different variations of it. And that's kind of what I'm going to ask you guys to do for your assignment. Okay. So you guys in third year, you guys are studying your like curtain walls. I mean, this is a great way to study different ways to divide that up into bays. Think about these. You might have a series of windows, and then you might have a series of like columns. So let's say we have our curve here, our base curve, and let's take this whole rectangle thing. And again, you don't have to do this. I'm just showing you as an example. If I divide curve, and I'm going to plug in my curve, I get a few points. Points go into rectangles. I've got rectangles, and then I'm going to extrude them into Z. And again, you don't have to do this. I'm just showing you. And then the height is going to be the same for those. And then let's play with the depth of them. So now I actually have a series of columns. So it's actually like a fence or something, right? But you can imagine that as one of your facades too, where those are maybe like engaged columns or things that penetrate that form. So you see what's going on there? So there are lots of ways to explore this. This has a circular section. These are circles. I mean, look at all the variation you can get, all of the different things you can actually study with this. This could be your building. This could be one floor of your building. And then I'll finish this. See, look at that. You've actually got the rhythm of that. Let's not forget that all this started with a curve. Boom. Okay. Now, you're not railing designers like by trade, but there's certainly opportunities here. There are things you can do. You could take any line from your building. You could take an edge. You could take two lines that are joined at an L, and you could explore that variation, right? And you could do this to explore like louvers, and this is exactly what we're going to be doing with it later, right? So there's lots of things you can do. I'm sorry, this is really messy here, but eventually you're going to go back and reorganize this and get these parameters set up. But I mean, just so much variation here, with this. Okay, so I'm going to go ahead and start a new file. You guys might want to save that for yourself. Again, this is all being like recorded, so you can slow this down a bit. But I just want to give you guys a sense of the possibility that the system has. Okay, let's go ahead and go back to our old standby, which is this single line curve. And we're going to start by referencing that curve again. So I'll let you guys get that. So just start a new file, make a line, reference it. So this is going to be like your homework, so pay particular attention. We do a lot of stuff with like datum lines, right? Like there's a line from which all things kind of spring. It might be the kind of base of your facade, and then there's the lines that define your windows, and then there's like your soffit. So that's what we're going to start by doing. So we can start by adding a move component. with a Z, and then a number slider. And let's set this to be the height, the total height of our of our facade. So let's say 18 feet is the most it's ever going to be. This is a study of a facade. Okay, and let's just crank it to 18. So we have our baseline, and we have the height of it. And let's just call this, let's rename this now. Let's say maximum height. So that way we know when we want that line later on, like I know what it is. It's not some move in some like anonymous collection of moves. It's the maximum height. It's a line. It's my datum line. Okay, it's smart. And then let's just make more lines. So take a copy of those, and then let's say that this line. And you can set a different range here. Let's say that the window, it's the maximum height for the base is going to be 3 feet, 3 units. And let's just call this window line. Okay, so baseline, and actually you could rename this too. Baseline. Baseline, maximum height, window line. So you can control this. You could control like this. So we got our collection of datum lines. Okay, and then let's make one more. Let's make one more line because we want kind of a soffit. So take this collection. Now the soffit, and when I call that is this line. It's like from here to here, right? So like whatever you've got the base, the window, and then the kind of soffit that's above that, right? The soffit line has to be less than the maximum height, right? Like it can't be up here. It's always going to be something here, right? So we can do a little bit of intelligent math here. I'm going to disconnect this. So I've got, let's call this my soffit. And let's do a subtraction component. So subtract. And this is really logical. You take A minus B, and you get the result. So A is 18. That's the height. And B is going to be some range of soffit. And let's say the maximum is 2 foot. So 18 minus 2 is 16. And so check that out. So now we have this line. And then when this line moves, it's smart. Okay? You could just make that like a move. But by making it dependent upon the maximum height, right, you're never going to violate that rule. Smart, huh? So this is your basis for your facade. Like you've got it, and you could have more lines than this. These are just simple like spring lines. Okay.
Can you do that? That's on your desktop?
Can I what?
No, that's just, I just want to see.
Yeah, I just have three. I have 3 lines. I have 3 copies. I just have my window line, which is moved, my maximum height, and my soffit line, and then the baseline. Okay, so lines all lined up. Okay, now we saw that when you have a loft of something, you can take 2 curves and you get a loft. So to make my window, which is the simplest kind of thing, I'm just going to make a surface. I'm going to take my soffit line and my window line and plug them in with a shift to get a window. And again, these are, this is parametric, so as I move this, my windows get bigger and smaller. So let's just call this window. Okay, and then we'll do another loft, and we're going to make this the base.
How can you put 2 values into the S as well?
Hold shift. Remember when you did your cross sections for the column? Yeah. Okay, so then for the base, I'm going to take the baseline and the window line. Actually, move this up here and plug them in, and so I get that surface. And then you guys know where I'm going with this, and then I have my soffit, which is the soffit line and the maximum height. So we've got 3 lines, and they're all parametric with each other. 3 surfaces, and they're all parametric with each other. Okay. Now, once you've got a loft, the reason why I did that is because then you can extrude a loft. So I can plug my loft geometry, my surface into extrude. And then, now which direction do I want to extrude it to make it solid? Look at my compass here. It's not Z. Y. So let's drop a Y unit. And then let's put in a number slider. And in this case, it's actually negative because we're going negative Y. So you can do like -2 or something. And see, now you've got thickness. And you can do the exact same thing. Like I can take this, copy it, and apply it to my soffit as well. So now I can make that even wider if I want to. You could do another extrude and then extrude it in positive, and then you get the other side of that window. So you might have a different thickness on the inside than you do on the outside, which is actually probably makes a lot of sense. Okay, so that you can see how that section is like starting to actually take shape. And again, if I change the height of these different things, and it's fully parametric. Okay. Now, before I let you guys go, I hope you guys see where this is going. So I could take my baseline, and I could divide it. Curve, and then I could take, and this is you guys can do a better job than this, but you could take your cylinders and take the height of the facade and plug it in. And you might get some columns in it, or some like window divisions. And you can start doing some horizontal divisions and some vertical divisions. And you can play with different like soffits, and you can play with like louvers and things. Okay. Don't forget that you can move things in this direction too. Actually like away from it, in order to create some variation. You could do some patterns where like every other column is like a square, or they're all square patterns or something. I mean, there's all kinds of variation you guys can do. But this is the kind of thing I want you guys to study. And this is kind of relevant to what you're doing in studio right now. I mean, you could study different kinds of patterns of things for a particular facade condition. It's a little dumb. I mean, you're not punching openings in it. You have to kind of infer that from the other geometry. But the logic of horizontal and vertical, of distribution, is really strong, and really powerful. You can control like all this stuff. Okay, so for your assignment, see what you can do with something like this. And again, I know you guys can do a better job than this. Try to add a bit more complexity. Look at like the depth of this thing. Look at the different kinds of rhythms that you can make. Maybe you have a regular rhythm and then you have randomness in another axis. Okay. So look at all the variations you can do and send me your 3 best examples. Okay, this is going to be just like last time. So you're gonna show me like a drawing of how you understand it. Give me 3 variations of it, and then show me the script that you used. Okay. Any questions? All right, I'll be around if you need me. This will be posted probably in the next hour or so.